Thank you very much, Melanie, for such a fantastic talk. As always, I will start with questions myself so that I give people time to get warmed up and ask their questions. So I'll start before we move to more technical stuff. I would like to understand your personal trajectory and how you got interested and involved in this area, and in particular how this very interesting combination of, let's say, more traditional AI back then with genetic algorithms and complexity happen.
Yeah, well, it was all very kind of random. So like many people in AI, I was very influenced by Hofstadter's book called Gödel, Escher, Bach, which probably at least some of the people in the audience have seen. It's a fantastic book that was published here in the US in 1979, but it was really about human intelligence, AI, consciousness, and all kinds of ideas, how they relate to ideas in art, music, mathematics. And I thought this is really the most profound question out there, is sort of how does something as complicated and ineffable as human intelligence sort of emerge from the substrate of neurons and connections. And so that was what really got me into the field of AI. And I decided to go study with Hofstadter. So I went to graduate school and got my PhD, but I happened to be going to the University of Michigan, where John Holland was also a professor. I had never heard of him. He was the founder of genetic algorithms, and he taught a class which was called Adaptation in Natural and Artificial Systems, which was really about how adaptation, biological adaptation, could be an inspiration for more lifelike computer systems. So that was also really grabbed me as a fascinating area. And I also ended up working with Holland. And he was the one who brought me as a visitor to the Santa Fe Institute, which is, then I became a faculty member there and started doing work on complex systems. So, it was kind of like everyone else. You happen to be in certain places that have people who really influence you and sort of change the direction or trajectory of your career.
What an amazing convergence.
Yeah.
Yeah. It is a fantastic book indeed, Gödel, Escher, Bach. It's one of my favorite books. Talking about books, as I mentioned in the beginning, I really enjoyed your books, especially the one on complexity and your most recent books. And I think you have an amazing ability to break down really complex ideas and to explain this to lay people. And you can see that in your articles and your courses and so on. So I was wondering, you seem to me to be like a natural teacher. So how do you see yourself? I mean, how these abilities, manifest themselves for you? Your combine your research career with this more educational. I had the impression that you extract a lot of pleasure from doing this kind of popularization of science work.
Absolutely. I've always loved writing. And I think writing and also teaching are the best ways to make sure that your own thinking is clear and that you really are thinking kind of deeply about the topics that you're researching. So it's very challenging, extremely challenging to explain like what's in your head to another person, something that you've learned about, say, neural networks or fractals or whatever it is, to try and explain it to somebody who doesn't have that knowledge. You have to have kind of a theory of mind of that other person or that audience, sort of understand what they know, try and explain what you know, and that also shows you sort of some gaps in your own understanding. So I think writing and teaching and research are all intimately tied together for me, and they all kind of complement each other and help me, in all three of those activities.
Okay, great, thank you. So moving on to more technical aspects, so why is it that without concepts there can be no thoughts, and without analogies there can be no concepts?
Well, as I tried to explain in the, by giving some examples, I think Hofstadter's definition of concepts as a package of analogies is a really good way to think about it. Like when we think about the idea of the concept of a bridge, or the concept of walking a dog, or really, any other concept that we have. A concept is not just a single word, although people sometimes use that shorthand, but really a concept is sort of a rich collection of models in our head about things in the world. And those things in the world can be sort of metaphorically abstracted, as we saw with bridge. We all understand when we hear Joe Biden say that he's the bridge to the next generation, we immediately understand what that means, even though there's no, we even get a kind of a visual, a visual feeling for like that him. We can imagine his body bridging from one generation to the next, and so this idea of concepts is really all about the analogies and metaphors that underlie these concepts. And I think if you're interested in concepts, you really should make sure you read Hofstadter and Sanders' books, Surfaces and Essences, which is sort of a, 500-page answer to your question.
Well, there is one passage of your book that you make a reference to that I like very much, in which you say that analogy making, you are quoting Hofstadter, in a very general sense, is the perception of a common essence between two things, right? And then you say this common essence could be a named concept, or it could be a concept for which we don't have a term. And these look more like a situation, a more complex package of roles and relations and so on. I like this very much because it brings attention to the fact that the analogy between analogy and classification, and even identification and identity, right? So classification is recognizing this common essence in different individuals of the same class, of the same category, but individuation as well. So identity is recognizing the common essence in different manifestations of the same individual. Would you agree to this?
Yeah, absolutely. We have this kind of spectrum of analogy making, and I tried to get at that in the book where you see like dog walking, we see two different dog walking situations, and we say, yes, that's really the same situation. But even, more abstractly, you might tell me some long story about your childhood, and I might say, oh, the same thing happened to me. Mm-hmm. But same thing, is actually extremely different in all of its details, but there's some shared essence there that we don't have a word for, but we still can perceive it. So it's really quite a spectrum of from just categorization up through very abstract sort of similarity. And one of my colleagues, Bob French, wrote a book called The Subtlety of Sameness, which is a title I really like, because sameness, things that we think of as the same, it can be extremely subtle how they are the same. Yes.
Yes, and again, I mean, this connects to this idea of identity, right? Because the same individual can change in a number of ways, radical ways from a perceptual point of view, but it's still the same individual because there is something which is maintained, right? It brings to mind another book called Sameness and Substance by the philosopher David Wiggins. And one of the points David Wiggins makes there is this idea that identity is attached to this notion of sortals, as opposed to just general types. So sortals like people or cars and so on, as opposed to heavy objects or red objects and so on. And you know, this is kind of a kind of metaphysical notion, right? So these notions of identity and how identities connect to particular types of types, which you find in work in cognitive psychology. You mentioned Elizabeth Spelk, but also there is this whole tradition of you know, Susan Carey, Sandra Waxman, Fei Shu, John McNamara before them, and so on, which connect to this kind of metaphysical work. But you don't see this so often in, let's say, in the cognitive camp in AI. So my question is, do you think that besides innate naive physics, we need to code innate metaphysics for AI systems?
Yes, I do. I think that that's one of the things that's lacking from AI systems. You know, there's this really strong, almost a religion in AI that everything should be learned. Mm-hmm. that you know, it's really the kind of the blank slate idea that we have, that you shouldn't build anything in. Everything should be learned. But I really do feel like AI is lacking the kind of, as you say, innate metaphysics that we humans have. And I don't think it can bootstrap itself there. Mm-hmm. Well, maybe if it had 1 billion years of evolution like we did, it could. But I don't think that the current approach in AI, which is just build these, you know, these neural networks and let them learn the statistics of these huge data sets. I don't think that's going to get us there, but that's my personal view.
I fully agree. Of course, one project, extremely well-known project in trying to build some sort of common sense reasoning for AI is the Psych project by Doug Lena. And so can you comment on that? I mean, we all admire the whole effort, but you seem to be kind of critical of the results as well, and you seem to think, and I agree, that this is not really a viable direction. But why do you think is that this is not the direction to go?
Well, I guess, I mean, there's many reasons, but one reason is that, you know, that the idea of psych, and there's other kind of approaches that are similar, which is either to sort of manually build in common sense, or to try and learn it from like documents on the web or whatever. There's so much about common sense that is not written down anywhere, or that's not even sort of consciously available to us as, you know, our own common sense. We don't even, you know, if I'm trying to write down everything that you need to know to have common sense, I would say, you know, 90% of it is what you might call dark matter, you know, things that I'm not even consciously aware of. Absolutely. That I just have learned, or either are innate, or I've learned very early on in development about the way the world works. And that without that foundation, it's going to be hard to actually have a robust kind of models of the world. So that's, you know, I think that's one of the problems. But that's those kinds of issues, that's a long discussion on
that's a talk in itself, right? But I mean, it's important to highlight that this is actually quite different from the discussion that we were just having. I mean, the idea that you find in cognitive psychology of having this kind of ontology underlying cognition, you are dealing with very general concepts, right? General notions of events and objects and space and time and causality and so on. This is a different project from trying to code common sense as a whole, right?
Right. And in fact, you know, there's people who are actually trying to work on this. So here in the US, we have this agency called DARPA, which funds a lot of research in AI. And one of the things they're trying to do is recreate human development from age 0 to 18 months. Get that, to have that kind of embodied learning of innate metaphysics, if you will. I don't know how successful that's going to be, but that's like a project that people are now saying this is something we should be doing.
I see. Interesting. Regarding coming back to the notion of concepts, I mean, so I really like this idea of concept as kind of a mental simulation or a mental model. You mentioned that one of the proponents of this idea is Lawrence Barcelow. There is another philosopher called Roman Frege at the London School of Economics that has a similar idea. And that, as we were talking about before, our previous speaker, Daniel Jackson, also has this idea of a behavioral notion of concept. This seems to be quite different from all different notions of concepts that we find in the literature, right? Ranging from a more symbolic notions of having definitions of properties to prototype theory to homeostatic clusters in the case of Richard Boyd and so on. How would that materialize in terms of representation? So this notion of concept as simulation would be this kind of a symbolic artifact or a different type of data structure? I mean, how would that be represented if you were to create a language to represent concepts as analogies? How, what would that look like?
That's a really great question, and if only I knew the answer. So there's been a lot of people who recently have been proposing sort of building intuitive physics. How objects, sort of a view of how objects interact, object constancy, all of that kind of stuff, but using sort of physics engines. Mm-hmm. And having like people, robots or what have you, learn from interacting with a physics engine like you would use in like a video game. And that this idea that representation is sort of a model that you build in this kind of physics engine language. Mm-hmm. So that's one view. But I think that the question you asked is totally open. Nobody really knows how that kind of thing is represented in our brains, and also how we would actually build this in a machine. So, that's super interesting, and I think will be the subject of a lot of research in the next decades. Mm.
You mentioned, when you were talking about concepts, you mentioned the importance of recognizing situations, right? So I was wondering, do you think things in the direction of situation semantics in a Bayesian sense, do you think they can play a role there?
Wow, that's a really good question. I don't know, possibly. I mean, I think people have to start thinking about how to represent situations. But again, you get into problems with very kind of formal logic-based issues, the same kind of issue that you get with the Psych project, that it's really hard to write down in a formal way, like all the semantics of a situation, when so many of them are sort of things that we know that we're not conscious of knowing, I think.
Absolutely. I think you make another good point in your book, that situations are not, I mean, let's say the limitation of situations is not obvious in the real world, right? Situations are not really well delimited.
Yeah, that's right. Mm-hmm. And that's been an issue in AI since the beginning, and people have talked about that for forever, but there's still no, this whole idea of open-ended situations like that we have in the real world. It's why AI is really good at playing games, which situations are well delineated, but have trouble sort of transferring that kind of approach to more real world situations.
One idea that came to mind is, I mean, I recently saw your interview talking about self-driving cars, right? And you mentioned something about this long tail characteristics of phenomena. I think this will be the case for almost everything, that the amount of situations we're going to find is there in the long tail, right? So it seems to me that there is absolutely no hope to deal with that if we don't have some sort of innateness and some way to do knowledge transfer from one situation to another that we haven't encountered before.
Yeah, absolutely. So in AI, that is analogy, right? What you just described is making analogies. And AI, people call that zero shot or one shot learning. and it's like the core problem of dealing with the real world is that we don't have labeled examples of everything in the world, and there's this, as you said, long tail of possibilities that could happen, meaning that there's so many unlikely possibilities that some unlikely possibility happening is very likely because there's so many of them, right?
Exactly.
One of the reasons why self-driving cars have such problems. So this really getting at what's the core of some of the biggest open questions in AI.
Mm-hmm. Talking about long tails and so on, I would like to connect, take the opportunity to refer to your previous work on complexity and in network science, right? I mean, most of the examples you find in network science are examples of, let's say, instance level networks when you're connecting food chains or cities or flights and so on. Of course, a type of a network is a conceptual model itself, right? And this is one of the really big difficult issues in conceptual modeling is that you have structures like, the foundational model of anatomy, which is a conceptual model with 100,000 concepts, and you have, DBpedia, and you have this whole linked open data movement. Do you think this work on complexity management in complexity theory could be transported to this area? Is my first question. And then, do you think we could observe in concept networks the same characteristics we find in other networks, like this long tail phenomena, scale free, and so on? Even if we think about concepts in your sense, I mean, the network of possible experience and simulations, would you expect to find similar characteristics there?
Yeah, definitely. I think that's an unexplored area, the whole application of network science ideas to these big ontologies, big models of concepts. Mm-hmm. I don't know if anybody's done that at all, and I would be really interested in seeing some work on that. And I definitely think we would see some of the same phenomena.
Mm-hmm. Okay, I will ask one final question, then I'll move, looking at the questions from the audience. And this is about, so if we take examples like even from Copycat, you have a fixed conceptual model, a fixed ontology, right? And then you can do analogy. I was thinking about all these different cases of analogy for concept evolution and concept invention and people doing things like conceptual blending and so on. If you could comment on that.
Yeah, so as I mentioned, a big limitation of Copycat right now is that it doesn't learn new concepts, and it can't like make new concepts up on the fly like you really need for more open-ended analogy making. And I think that's something that I would really like to be able to incorporate into these models. And conceptual blending is one example. I was really interested in the work of Franconi on this, and also just being able to kind of create new ideas. Like I remember I talked about that Bongard problems, and there was the one with the neck, and that's like you really haven't applied that concept of neck to that kind of figure ever before in your life, but it's very natural. So to be able to do that on the fly is really important. And so I see that as like the next big challenge in these kinds of models. Mm.
Very good. So I'll move now to the questions from the audience. So the first one is, a current discussion is how to evaluate an AI system, especially because of the dependence on language skills. As you pointed out, often language models perform well, but for the wrong reasons. This can be attributed to the evaluation process, which has been mostly language dependent. What are your ideas about this?
Right, so evaluation in AI, it's kind of a crisis right now, I think, because the way that a lot of papers are published, it's like, we got this, state of the art accuracy on this benchmark, and that's like that's it. So that's really led to this whole problem where these systems are being evaluated in ways that don't really show their generality, their robustness, their ability to transfer. So I think all of these things have to be kind of built into the evaluation proceedings, and there has to be a much broader kind of view of evaluation than just looking at accuracy on some benchmark. I don't know exactly what that should look like. I think that should be the focus of some important discussions and research in the community. And perhaps, you know, I don't think the AI community has really looked very much at like more cognitive science ideas of how this might be done, of how to evaluate sort of general intelligence in humans. And I would be interested in thinking about and talking to people who work on that kind of thing. So that was kind of what this Francois Chollet from Google was trying to get at in his paper, where he was talking about measuring intelligence and how to evaluate these systems. And he had a lot of really interesting ideas.
It seems like a nice paper. I'll definitely check that out.
Yeah.
And so there is a reference to a recent article you wrote, but phrased as a question. Of course, I invite people to read the article, but maybe you want to comment on that. So, can GPT-3 make analogies?
Right. So I don't know if everybody knows what GPT-3 is, but it's this extremely large, what's called a language model that was created by this company, OpenAI. It was trained to really complete, like given a piece of text, complete the text, complete the sentence, or give us the next words. And it was done on, you know, millions and millions of web pages and books and Wikipedia and so on. So it's a huge model. And I got access to the interface for it and gave it some copycat analogies, and it could do some of them and it couldn't do others, and it's just kind of hard to evaluate. And I would say that it like just like it has the appearance of being able to converse with you or write its own text, and it really has this very strong appearance of understanding. There's so many cracks in the facade of understanding that you can see that it is not able to make analogies in a way that's generalizable at all. So that's what I would say about it. You know, and then there's this big question: is this kind of statistical approach where you just throw more and more data at the system and make it more and more, have more and more parameters in the system? Is that really going to lead to something like human-like analogy making? That's very much an open question. I would predict no, but other people disagree. So I think that's a big debate now. But you know, my little article was just, it wasn't meant to be kind of a definitive answer on the topic, but just kind of opening up the question.
Very good. So there is one comment here, which is actually quite interesting. We can unpack it in many ways. So the person is actually, making the point that when you define concepts as packages of analogies, you are making an analogy because you're using the notion of packages, right?
Right.
So I guess the implicit idea here is that, I mean, how do you avoid some sort of regress, dangerous regress? I mean, how do you stop this? I guess would have to be with innate concepts somehow, right? Sort of right. Body experience, I don't know.
Yeah. So yeah, is it analogy all the way down?
Yeah.
Well, I don't know. You know, there's the work of like Lakoff and Johnson and
absolutely, yes.
All these other people on metaphors, and how all of our abstract concepts are grounded in physical, bodily sort of experience. You know, if I say, thank you for the very warm welcome, you know, warm is a bodily experience, warmth, right? And so maybe it all comes down to embodiment. I'm not sure. I think that's part of it. but that may be the answer to the infinite regress. I think that's an interesting speculation. And that is a great question. You know, of course, it's hard to speak without making analogies. We don't even notice most of the time. Yes. But yeah, so that was a great observation.
Thank you for the very interesting talk. I was wondering on your take on how the Copycat architecture could be applied to new abstraction and reasoning, to the new abstraction reasoning corpus. Would it be applicable, or would it maybe have to be adapted to be able to deal with these problems compared to the letter string analogies?
It would definitely need to be adapted. You know, I think it would have to be sort of an architecture that has some of the key characteristics of Copycat, meaning this sort of dynamic interaction between more top-down concepts and bottom-up perception. I think that would be a really interesting approach to take, and I'd love to be able to adapt some Copycat ideas to that arc corpus. I think it would take a lot of work to get something like that working, but it might be worth doing. It would be a great project, and maybe someday I'll have time to work on that.
So someone says, in my ontology work, I'm developing ways to accommodate varying worldviews, so varying ways of looking at the world in the same model, right? So I don't know if that's exactly the view, but people, for example, are working on different granularities or different perspectives that might even be inconsistent when taken together. So people don't see the world the same way, and we get better results when we look at problems from multiple perspectives. Is AI research looking to the idea that multiple ways of seeing the world might give better results?
I think there's some notion of that and some work in AI. You know, there's been a lot of different approaches. So there's this approach of ensemble learning, where the idea is you get multiple models learning and you try and make them as independent as possible so that they are looking at things in different ways. And those kinds of ensembles have had a lot of success. There's also notions of like blackboard-like architectures, sort of like Copycat, where you have all these different hypotheses being considered simultaneously. And so they have kind of different ways of representing what's going on. So yeah, I think that's a great inspiration, that kind of thing that we have in human society, where, you know, multiple ways of looking at a situation will actually perform better than just like a single tunnel vision. I think that's a good inspiration for a lot of things in AI, and people are thinking about that, but maybe not enough.
Mm-hmm. Thank you for a very insightful talk. Quote unquote, what did the model actually learn is a very important and difficult to answer question. What is your take on using AI for detection of fraud by governmental agencies?
Oh, wow. So that's a little bit out of my expertise. I think that there's a lot of potential there. You know, when you say using AI, there's a lot of different approaches in AI. It's not like a unified approach. So there's certain approaches that might work well for that kind of data. I mean, I have some of my students, my former PhD students, are working at companies sort of doing fraud detection in various ways, and they're using machine learning algorithms. So and they report that it's pretty successful. So I would say, yeah, that's probably something that a lot of people are working on that maybe you can have, you know, but you have to be careful because these algorithms, you don't know exactly what they learned. And we've certainly found that not only can they learn the wrong thing in terms of what you're trying to teach them, but they can also learn things that are actively harmful, like biases, like gender, racial bias, things like that. So you have to be really careful in using these kind of black box algorithms in areas that affect people very directly like that.
That's a good point. Another part that reminds me from your book is this idea that you advance that moral reasoning is not different from different types of reasoning, and the advance that we need there would be similar, right? And I fully agree. I think in terms of, again, if we think about all these different situations we can encounter in this kind of long tail phenomenon, and we would really need to have a basic, maybe innate understanding of fairness, of trustworthiness, and so on, right? So we would have to have a kind of conceptual clarification work done such that machines can understand this notion of fairness or trustworthiness, for example.
Absolutely. I mean, you know, a lot of people cite like Isaac Asimov's robotics stories. He has his, you know, 3 laws of robotics, which are things like, you know, the robot should never harm a human, etc. But all of his stories are about the fact that the robots don't understand those laws in the same way that humans do, and so they misapply them.
Yes.
And you get into big trouble because they lack that kind of conceptual understanding. That's how I read his stories. And I think the AI is kind of falling into this trap now of, oh, well, we have to program morality into our systems. We have to have systems that have compatible values with our values and all of that. And that's really so difficult if they don't have concepts.
I fully agree. And analogies, right? Because of this unboundedness of moral situations you can find yourself into.
Exactly.
Right. There's another question here regarding if you think that a breakthrough in theoretical computer science, for example, is needed, or is just a matter of you know, having more data and more computational power for achieving human level intelligence?
Well, if you ask me, I would say yes, we need a breakthrough, and more data isn't going to get us there. But I'm, you know, maybe not in the mainstream of AI on that view. There's at least some people who think that really it isn't. We are, you know, deep learning is going to get us there. Just we need more deeper networks and more bigger data sets, and we'll, you know, the systems will be able to teach themselves. So I guess it remains to be seen.
Mm-hmm. There's another question, I think, related to that. So the question is, who's currently winning the war, statistics versus semantics?
Winning the war. That's great. Well, it depends how you define winning. If winning is like funding for research, mm-hmm. I think there's kind of a turning point in. You know, there's still, statistics is still dominant in AI, but I think people are beginning to wake up to the limitations of it, and they're seeing some of these issues, they're seeing some of these vulnerabilities, and there's more and more talk about how we need to kind of have more hybrid architectures. People are talking about neuro-symbolic architectures, or talking about more like looking at developmental psychology as an inspiration for AI. So I think that the tide is beginning to turn, and it may be that semantics will become more prominent in the field. So we'll see.
Sometimes I have the feeling that, as you quoted recently, we are 100 Nobel Prize away from this anyway, right? I have the feeling we are doing 16th century chemistry, alchemy. So we are really far from anything that will work anyway. So it's hard to predict, right?
Yeah, exactly.
A basic assumption underlying the approach discussion seems to be atomism, the idea that global structures are made up of local structures. What if the biological cognition doesn't work with this assumption? Because biological systems always come with an environment. They might start with the global and just scale up or down global structure, always. Biology might be working with spiral metaphysics rather than additive metaphysics.
Well, as a complex systems person, I sort of agree with that. That the reductionist approach isn't the right way to think about intelligence. But yeah, so I think that in AI, for example, we don't really know how to think about these sort of non-reductionist methods very well. So I'm not sure how to answer that question besides to say, yes, I think that that is a big issue.
Still talking about complexity, I don't know if you have been following this trend on network science applied to digital humanities. There is this recent book by Neil Ferguson on the square and the tower, and there are many examples of that. And are you following this? And could you comment on that, on this work on, you know, most of the work I see on digital humanities these days is connected to network science.
I'm following it a little bit, not extensively. I've seen some of it. I don't really know what to think about it. You know, I think that it's a really, it's interesting, but I haven't really seen a lot of like deep insights come out of it yet. I'm not, I have to say, I haven't followed it that closely.
Have you seen anything interesting applied to COVID?
To COVID?
Yeah.
I have seen, I mean, some of the network analyses, you know, are really important. And I think it, you know, people, as we say, people tend to think in very reductionist terms, which leads to certain strategies for dealing with COVID that network science might lead to other kinds of strategies. Like, for instance, you know, how this idea of these network properties like scale free or small world properties might lead epidemiologists or vaccine scientists or others to have somewhat different strategies than otherwise. So you know, I mean, one obvious thing is people talk about this R0 number, which is the kind of how many people on average are infected by a infected person, but R0 is an average.
Absolutely. So it takes diffusion of COVID as a normal distribution, right? It seems to be crazy.
And it's assuming, it sort of assumes a Gaussian, you know, if you can talk about this kind of well-defined average. But if COVID's like, in terms of, it's more like a power law, like with all these super spreader events, R0 is not the meaningful parameter. It's not the thing we should be looking at. And I've seen some articles talking about that, which I find very useful.
I'll ask one last question. There was an interesting ruling in the UK this week that you may like to look at. This was about facial recognition. The judge ruled that it was unlawful on 3 points. One of these was that the police force did not take reasonable steps to find out if the software had a racial or gender bias. That is, it didn't matter if it turned out there was no bias. The force could not use the new tech until it was demonstrated. Did you follow this? This is not the first case, right?
Yeah, I'm not sure which case this was, but I know there's been a lot of cases on that. And I think that most people in AI research feel that facial recognition is not reliable enough. It's infused by biases, not just in the data, but also like even in the cameras, in the way that the digital photos are processed, that there can be sort of skin color biases, and it's just so kind of rife with possible problems that it really shouldn't be used in criminal for police forces or all those anything like that. There's just too much of a danger of civil rights violations, and I think a lot of companies are coming around to that too. So, and I know a lot of cities in the U.S. have banned facial recognition for police forces. I'm not sure about Europe. Europe's usually ahead of us on that. So I'm hoping that, you know, people are going to sort of regulate it in that way more widely.
Melanie, we still have questions and comments here. I'll make them available to you. I think we have to wrap up. I could stay here the whole day talking to you. Thank you very much, for the generosity of giving this talk and staying here answering all these questions. This was fantastic. Thank you very much.
It's been my pleasure. Thank you so much.